Hello everyone, welcome to my YouTube channel. So here today we are going to be doing our introductions to functions. So what is a function? So a function is simply a relationship that takes an input and produces only one output. So this is our definition of a function. So you only have, let's say, an input, it should produce only one output. So now under functions, it is possible that one input can produce only one output, but it is also possible for two different inputs to produce one result. I'll clarify this as we look at examples. But if one input produces two different outputs, then it is not a function. So now, to elaborate this more, what I'm going to do is I'm going to use this diagram. Let's imagine that this is a test. If this is a test that is out of 5, then we have x and our y. So our x, this one is what we are going to be calling our domain. This is what we are going to be calling our domain. So our domain is made up of Moses, Mark, Joshua, and George. These are the people that more like wrote the test. That's your domain. So domain for this one is Moses, Mark, Joshua, George. Then this one, the 0, 1, 2, 3, 4, 5, this one is what we are going to be calling our core domain. So if this is a test, there's a possibility of someone having a 0, a 1, a 2, a 3, a 4, a 5. So all these possibilities of getting any mark, that is what we are going to be calling our code domain. Now, to define our range is actually what did the people actually get. So the code domain will be made of everything there. Then the range will be what did people actually get. So now, in this case, let's say our Moses gets 2%, or rather a mark of 2. Let's say Mark gets a 5. Let's say Joshua gets a 2 as well, like that. Then let's say George gets a 4. So now the range is what marks did these people get. So the range for this one will be a 2. Someone managed to get a 2. Another person managed to get a 4 and a 5, like that. So this one is what we are going to be calling our range. Then our code domain is every mark that was there. So our code domain is the whole thing, 1, 2, 3, 4, 5, including 0, since there was a chance of getting a 0. So the code domain is made up of everything. Then the domain is what was used. So in this case, the people who participated were Moses, Mark, Joshua, and George. So now, as we said, one input. So let's say Moses has got only the ability of just getting one mark. So if let's say Moses gets 2%, it means to say he has gotten 2%. There's no possibility that this same Moses, the input, can produce two outputs to say Moses got a 2 for the same test, but at the same time they got a 0. That wouldn't make sense. So if a person gets a 3, then it means to say they have gotten a 3. So one input can only be able to give you one output. Now it is possible that Joshua and Moses got the same score, therefore they got a 2, both of them. That one is allowed because 2 inputs, or maybe even 3 or more, can get the same result. So this one is a function in the sense that each one has got just one element. So it doesn't matter whether Moses and Joshua have got the same mark, but the fact is that each one, if we are talking about just Joshua has just gotten a 2. It's not possible for Joshua to get a 2 at the same time get a 5 for the same test that was written once. So it wouldn't make sense like that. So this one is a function. Now on the other hand, this could not be a function if, now let's say we have this one we are going to say that this one is not a function. So this is not a function because there is an x value that does not have a y value. In other words, Moses here is not recorded to have any mark. Now you can just use logic to say as long as someone writes the test, we expect them to have a mark as long as that paper was marked. If not, that means to say it's not a function, because a function, each input must have an output, but it is okay for a certain output to not have something that it is bonded to, because it is an output and there is a possibility that not anyone would get a 0 for that test. Like that would happen. So yeah, this one we are going to say it is not a function because the input for Moses has no output like that. In the same line, this one is also not a function because already one x value has got two y values. Moses, let's say Moses for the same test as a 0 and also as a 1, that wouldn't make sense. So if Moses has got a 0 at the same time they have got a 1 in the same test, that would either be the beginning of witchcraft or quantum physics. But anyways, let's not get into that. But as long as the output has got two different results, it simply means to say that's not a function, because a function should have one x value, just be able to just produce one y value, or the other case is that two x values can be able to produce the same value. As we know to say, even in a test there's a possibility that others might get the same mark, but it is not possible for one person to get two different marks for the same test. So this one, if it looks like this, then this is not a function as well. So we are getting somewhere with this, even as we are able to understand other things. So now let's identify other questions. Let's say for our first one, our A is saying that y is equal to 3x plus 2. Now we want to test whether this one is a function or not. So this one automatically is a function. So this one, all linear equations are functions. So it is a function. So what we are going to be using is a vertical line test. So using the vertical line test, so for the sake of this video, do not worry about how we are going to be graphing some of the equations. We are going to cover that in the later tutorial. So let us use our vertical line test to show you how this is a function. So if our y is equal to 3x plus 2, so to graph this equation, it's very easy. This is a linear equation, so we only need 2 points. So at one point we need where x, we have our y. So we have our x, let's say our x value is 0, so replacing 0 there. Then for our other value, our y should be 0. Just these 2 points are enough. So if I put my x to be 0, I'll have y should be equal to 3. Where there is x, I'll put 0. Then I'll have plus 2. So this is y should be equal to 3 times 0 is 0 plus 2. So my y will be equal to 2. So I'll put it here. Now when my y is equal to 0, what I'm going to have is that where there is y here, I'll put 0 should be equal to 3x plus my 2. Taking the 2 the other side, I'll have a negative 2 should be equal to 3x. I divide by 3, I divide by 3. Then what I'm going to get is my x is equal to negative 2 over 3. Now negative 2 over 3 is approximately negative 0. We add a 0. 20 divided by 3 gives us a 6. Remainder a 2. We add another 0, so the 6 will continue, 6 6 6. So we are just going to write a 7 there, like that. So this is our negative 0.67, like that. So these points are enough to draw a linear equation. So we are going to just be able to use these 2 points and say we have a 0 comma positive 2. So 0, so we have our x, our y here. So 0 comma positive 2 is here. So let's say my 2, let me put it here, let's say my 2 is there, so it's passing at this point. Then the other thing is that we have where y is equal to 0, it's along the x-axis. So let's say this is my 1, so 0.67 is somewhere here. So now when I connect these 2 points, so just those 2 points are enough. So when I connect these 2 points like that, I'm going to have an equation that will look like that. So now, as you can see, this equation is a straight line, which is our y should be equal to our 3x plus 2, like that. Now you will find that at all points, each x value has got its own y value, like that. So like for example, if I say my x value, let's say here my x value is equal to let's say my x value is equal to 1. If I put 3, if I put 1 where there is x, I'll have y should be equal to 3. Where there is x, I put this one, then I have plus 2. So my y will be equal to a 5. Now, due to the fact that my y is equal to a 5, it means to say the only point that the x and y will meet, it will only be 1 point. In other words, what this tells you is that the x and y only have, at all points, only one x value will correspond to one y value, like that. So that means to say so this is how we use the vertical line test. You just cut like that the vertical line. If your vertical line only meets your given equation at one point, it means to say it is a function. But it is not a function if your line cuts at 2 or more points. Like for example, if we look at this, at all points that you will be able to cut, this line will only meet this vertical line will only meet your given line at only 1 point. Then therefore it is a function. Likewise, if you have an equation that is saying that y should be equal to x squared, so just as I have said, don't worry about how we graph this for now. So we are going to be looking at something like this. So y is equal to x squared is a graph that looks like this. So it is a graph that looks like this. It is a quadratic equation that looks like this. Now you will find that a quadratic equation, y should be equal to x squared. Just a simple table of values to make you understand a bit. We have x, we have our y. If I put x to be 0, I'll have 0 squared, which will be 0. If I put where there is x, I put 1. 1, if I put it here, 1 squared is equal to 1. If I put 2 here, I'll have 2 squared, which is equal to 4, like that. So now this is continuing. So as long as I have a 0, it's comma 0. As long as I have 1, it's comma 1. As long as I have 2, it's comma 4 at that point, like that. Now the same with the negative. As long as I have negative 1, the outcome will be positive 1, because if I say y is equal to x squared, where there is x, I put negative 1 squared, then that means to say I'll still get a 1. So therefore, using the vertical line test, as long as you have drawn a straight line like that, then it simply means to say your equation is just meeting your other graph at only 1 point. Then it is said to be a function. If it's meeting your equation at 2 points, then it is not a function. Like for example, let's look at this equation, the equation of a circle, our c, which is our x squared. So we have our x squared plus our y squared should be equal to a squared, like this. So just not to say, as long as you have your x squared plus your y squared, both of them are squared, then you have something like a squared. It could be c squared, it could be r squared, or any letter squared. Then this is the equation of the circle. So just as I said, don't worry for now about how to sketch this. Just not to say, if you have squared, squared, and squared there, then that's the equation of a circle. So the equation of a circle, which will look like something like this. Now as you can see a circle like that, then you will find that if you draw a line, or rather if you draw a straight line like that, this straight line touches the y-axis at 2 points like that. Let's say just for the x that is equal to, let's say, 1, it will be able to touch, let's say this point is a -2, and let's say this point is a +2. Then it means to say x is equal to 1 produces y to be equal to +2 and y to be equal to -2. Now, due to the fact that that's the case, it means to say this is not a function. So you can say it is not a function. Why is this not a function? Simply because your vertical line is touching the y-axis at 2 different points like that. So if that's the case, that means to say it is not a function. Let's look at our D. Let's say we have our y squared is equal to x. So to graph this one, we are going to introduce the square root. So that y just becomes equal to, now immediately you introduce the square root, you are going to have plus or minus the square root of x like that. Now, just as I have told you, don't worry about how to graph these for now. Then as long as you have such type of a situation, you are going to have something like this. Your graph of a radical equation looks like this. Now, due to the fact that it's plus or minus, it will also go down like that. So now, due to that factor, we are going to have, if you draw your vertical line, let's say at this point x is equal to -3, then let's say at this point, okay, at any point, let's say at this point x is equal to +3. So what will happen is this. So if you draw your vertical line like that, then your vertical line is met at 2 different points like that. At this point where y is equal to -3, and at this point where y is equal to +3, then it means to say this one, it is not a function. So as long as we have 2 different values of y for one equation, that means to say it is not a function. Let's look at y is equal to the square root of x. Now, if you have already been given y is equal to the square root of x, then this means to say, if you draw your equation, now due to the fact that it's already put in a square root, that means to say you are just going to consider your positive, so the graph will look like something like this. Now, get the picture. If you put, let's say, y is equal to the square root, if it's already given the square root, let's say x is equal to 4. We are just going to consider the positive and say y is equal to 2, as long as you have already been given the square root like that. So now, due to this factor, to say as long as I have such a situation, I'm just going to be producing positive. If you say y is equal to, where there is x, you put 1, it will be y is equal to 1. So in other words, as you increase the values of x, you will find that even the values of y will be increasing. They will be meeting at this point, reducing like that. So that is the way it is. Now this equation looks like that. Then what we are going to be doing is this. In order for us to identify whether or not this is a function, we are going to draw a vertical line. So that's our vertical line. Now, if this vertical line touches the graph at only 1 point, then that means to say it is a function, because one x value only has one y value. So that means to say this one is a function. So you can say it is a function, because let's say here it is equal to +3, and here let's say our x value is equal to a 9 like that. So just x is equal to 9 corresponds with a y is equal to 3. So it's okay. What we want under this one is that just one x value should just have one y value. However, let's go back a bit to, let's say, our d, which is saying that y is equal to x squared, like that. Now we are going to do this to elaborate something like that. Now if you have something like this, so this is the equation of a quadratic equation for y is equal to x squared. So if this is the case, what we are going to have is that, let's say one y value is produced by let's say you have a 9. If you put 3 here, it will be 3 squared, which will give you 9. Now whether you put 3 squared or you put negative 3 in brackets squared, it will still give you 9. So that means to say this 9 is being produced at 3. It is also being produced at negative 3. So now, due to the fact, if we draw a horizontal line, which is a line that will look like this, you will find that this line touches the 2x values. So you can find that for the x value, x is equal to negative 3 and positive 3. Your y value, y is equal to just 1, which is okay. Remember, we can have 2x values producing the same y value. That is very, very much okay. So as long as it just satisfies this vertical line touching just one portion of the graph, then that means to say it's a function. Thank you very much for watching. So that is the introduction to identifying functions. See you in the next tutorial, where we are going to be talking about piecewise functions and determining whether they are functions or not.